Yeah, good evening, children. Good evening, online students. Good evening. Good evening, children.
Good evening, ma'am.
Good evening.
Good evening.
Yeah, good evening. So, we're going to start heights and distances today. I've checked once earlier that all of you have completed this chapter in school. So if I give you the introduction, like what is angle of elevation, what is angle of depression, it might be boring. You will not listen. So I'll start off with the questions directly. And while explaining the answers, you can get your doubts clarified if you have any. So the only thing I have to say about this chapter is about angle of elevation and angle of depression. All right. So that we'll learn it through the sums itself. All right. All right, children.
Yes, ma'am.
Heights and distances. Oh, it's not done in your school? You have also not learned? You have completed. Oh, you have not done, is it? Okay. Meaning your section. Okay. Krishmi, have you learned this chapter in school? Applications of trigonometry? She cannot use her mic. Okay. Okay, the others, online students, please raise your hand if you have learned this chapter. If your school has completed heights and distances, meaning some applications of trigonometry in school. Okay, fine. Yeah. We'll do together. Yeah, take down the question, children. And I'll give you some time, about 5 minutes time. Try to make the figure for this. Finished? Okay, what's the answer? Meaning the diagram or the answer? Yes, what's the answer? 6 divided by? Oh, no. The number is right. 6250 is correct, but the answer is just 6250. All right, children. So I'll just tell you the, you know this, your teacher has told you in school, but we'll just recall the basics of this chapter. So here we have two terms, right? Used angle of elevation and angle of depression. Angle of elevation and angle of depression. Now so an angle has two arms. An angle has two arms. So likewise, an angle of elevation and angle of depression also has two arms. Now the arms of this angle are called the horizontal and line of sight. The arms of this angle are called the horizontal and line of sight. Now I don't have my line of sight with Navya, so Navya, please. Okay, so these two arms, so an angle has two arms, right? Now the arms of the angle of elevation, they are called the horizontal and line of sight. So where will you mark the angle of elevation? You will mark it between the horizontal and line of sight. Okay, now let's understand what we mean by horizontal and line of sight. So supposing there's an observer on the ground. Okay, so this is the ground level. This is the ground level, and there's an observer on the ground. There's an observer on the ground. When we know the height of the observer, we use a line segment. When we know the height of the observer, then we use a line segment. If you do not know the height of the observer, then we represent the observer with a point or a dot. When you know the height of anything, when you know the height of the building, see, I won't say when you know the height of a building. When it's a building, you will show a line segment. Okay, when it's a building, you'll show a line segment. When it's a person and you don't know the height of the person, you represent the person with a fine dot. If the question talks about the height of the person, then we use a line segment. If the question talks about a person, but not the height of the person, then we don't use a line segment to represent the person. We just use a fine dot. Otherwise, for other structures, buildings and all that we use, or something is flying high in the sky, then we use a line segment to show its vertical height from the ground. Now, supposing there's a cloud high in the sky, then we use a line segment like this, which represents the perpendicular height of the cloud above the ground. So we'll be using line segments to represent, to represent structures, buildings and all that, or to represent, here we use the line segment to represent or to show the height of the cloud above the ground, the vertical height of the cloud above the ground, right? And with the person, height not known, just a dot. So now supposing, so this is the ground level. This is the ground level. There's a person here and he looks at the cloud. He looks at a particular point on the cloud in the sky. Okay, so now so let me just mark the point like this. So this line segment connecting the eye of the observer and the point observed is called the line of sight. It's called the line of sight. The line segment connecting the, so when I say this is the observer, that's the eye of the observer. He's looking at something, no? So this is the eye of the observer. The line segment connecting the eye of the observer and the point observed is called the line of sight. Sight, seeing, sight. Okay, so you see, no? So sight, line of sight. the line of your vision, you know. Okay, so the line segment connecting the eye of the observer and the object observed is called the line of sight. Now, through the eye of the observer, we take a horizontal. Now, in this case, it's a ground level because we do not know the height of the observer. We don't know. See, supposing we know the height of the observer, you know, this is the ground level. This is the ground level. Supposing you know, or you have to find the height of the observer, then you have to take, you know, you'll have to represent the observer with a line segment like this. Then the horizontal is this one. Then this is the ground level. This is the ground level. This is the horizontal. The horizontal is always a straight line drawn through the eye of the observer. So this is the foot of the observer now. Now this is the foot of the observer. This horizontal is a ground level. He's standing on the ground. That's a ground level. That's not the horizontal. It's a horizontal, but that's not the horizontal which we use for angle of elevation or angle of depression. So now this is called the ground level now, and this is the horizontal. The line drawn through the eye of the observer is called the horizontal. But here the ground level itself is the horizontal. Here the ground level is also the horizontal. In the first case, when we do not know the height of the observer, then the ground level itself is a horizontal. When you know, or when you have to find the height of the observer, then this is the foot of the observer. This one is the ground level, and this is the eye of the observer. The line through the eye of the observer is called the horizontal. So the angle between the horizontal and the line of sight is called the angle of elevation or the angle of depression. If the object is at a higher level, then it is angle of elevation. If the object is at a lower level, the observer is at a higher level, then it is angle of depression. Now in this case, you see this is the ground level or the horizontal. This is the object observed and this is the eye of the observer. This is the horizontal, we understand that. This is the line of sight. Now this angle between the horizontal and the line of sight is called the angle of elevation. Angle of elevation. Now, if we know the height of the observer, same situation. If we know the height of the observer, then this is the ground level. This is the observer. This is the horizontal. This is the cloud. Okay. Then we draw. See, you'll have to fix the vertical line. You'll have to start from here because this is the ground level. You should not stop here. You should come here because this is the ground level. From here is the height of the cloud. From here is the height of the cloud above the ground. Now the doubt is, should I draw like this or should I draw like this? That's my doubt. The thing is, the line of sight does not connect the foot of the observer and the object. How does anybody see? Eyes. So the line segment connecting the eye of the observer and the object observed is the line of sight. So this one is not at all in picture. This one has no meaning. That's not the line of sight. Let me put it like that. That's not the line of sight. Why? Because you're connecting the foot of the observer and the object observed. That has no relevance at all here. We need to connect the eye of the observer and the object observed. This is the horizontal. This is the horizontal. Why? Because the line through the eye of the observer is the horizontal. And this is the line of sight. Eye, object observed. Now the angle between the horizontal and the line of sight is called the angle of elevation. So this is when the height of the observer is known. This is when the height of the observer is not known. So you should draw the horizontal through the eye of the observer, and the line of sight is the line segment connecting the eye of the observer and the object observed. Between these two, because an angle has two arms, between these two line segments is the angle of elevation in this case, because the cloud is high up, the observer is down. So angle of elevation. Angle of depression is, see, this is the ground level. Say this is a multi-storied building. This is the ground level. This is the multi-storied building. And you are standing here on top of the building. Height not given, or we are not talking about the height of the observer here. So a fine dot. This one is the observer. This one represents the observer. This is the multi-storied building. Multi-storied building. And this one is the ground level. That's not the horizontal, that's a ground level. It is horizontal, but it is not the horizontal which we talk here in this chapter. It is the ground level is horizontal, but that's not the horizontal which is needed to mark off the angle of elevation or depression. Okay. Now, so this is the this line segment represents the multi-story building. This line segment represents the ground level. Now the observer is here. There's a car moving on the road. At a particular, the car is moving. Okay, fine. A car is parked on the road. Let's say a car is parked on the road. The car is parked here. Now the observer looks down at the car from the top of the building. So this is the eye of the observer, and he's looking at the car. This is the object observed. So this is the line of sight. This is the line of sight. Now the horizontal. The horizontal is always drawn through the eye of the observer. Now don't draw it this side. It has no relevance. Don't draw it here. Okay. Okay. He's looking down, meaning he's looking like this. No, that's the line. That's the horizontal. Don't draw like this. That's his back. That's from behind his head. Not there. Okay. So not this one. He's here. He's looking like this. He's looking down like this. So through his eye, this one is the horizontal. The horizontal is always a line through the eye of the observer. Anything horizontal should not be taken as the horizontal. Ground level is horizontal. Okay, so that's the horizontal. No, the horizontal is a line drawn through the eye of the observer. Now the angle of elevation. Which are the arms of these two angles? Angle of elevation or angle of depression. Which are the arms? Horizontal and line of sight. You should mark these angles between the horizontal and line of sight always. Simply because there is something here, this cannot become the angle of depression, or there's something here, so angle of elevation. Not like that. You should make sure that you're marking the angle between the horizontal and the line of sight. So here, this is the horizontal and this is the line of sight. This is the angle of depression. You'll wonder it's outside the figure. Yeah, it is outside the figure. It is outside the figure. See the definition. This is the horizontal. This is a line of sight. Between that, this one, not this one. This is the horizontal. This is the horizontal. This is the line of sight. Between those two, horizontal and line of sight, this is the angle of depression. And we know that these two, this horizontal and the ground level will be parallel to each other. So alternate angles are equal. Alternate angles are equal. So angle of depression will be equal to this one. That means in any case, the angle of elevation will be equal to the angle of depression. Like if you switch the places, you come down. See, supposing this angle is measured to be something like 75 degrees, say. Supposing this one is 75 degrees. Now, supposing you come down and stand here and you look at this point where you were standing earlier, the angle of elevation also will be 75. If you switch the places, from here you look down, the angle of depression is 75 degrees. Suppose you come down the multi-story building and you come and stand at that point where the car is parked, and you look up at the point where you were standing earlier, some time back, So from here you look up at this point, you will see that the angle of elevation measured is the same, 75 degrees. 75 degrees. The angle of depression will be equal to the angle of elevation. Alternate interior angles are equal. This angle is equal to this angle. So it's very crucial to mark the angle of the position of the angles correctly. If you can do that correctly, you cannot go wrong in this chapter. So only this, then the rest is all dependent on trigonometry. And how to solve, after using trigonometry, how to solve is all about, we've seen in linear equation, the substitution method. We'll come to that. Okay, so the rest of it is very easy. So you'll have to take utmost care in making the diagram correctly, marking the angles in the right places. If you do that, you're like half done. Your work is half done, half correctly done. Okay, so now Navya is waiting for this answer. Okay, you tell us the answer to this question. I'm getting 6250 by 6. Huh? Right. Okay, all right. Now coming to this question, children. So that's about, a line of sight, horizontal, angle of elevation, angle of depression. All right, that's it. Now see this, an aeroplane when flying at a height of 3125 meters from the ground. Okay, so We need, so this is the ground, this is the ground level. We'll not take the ground level now. Okay, I'm just telling you this is the ground level. So this is the aeroplane. At what height is it flying? When flying at a height of 3125 meters. So say like this here. Okay, it's flying at a height of 3125 meters. So this is the ground level. This is 3125 meters. This is the aeroplane. This is the aeroplane. Let's mark that point as A. A is the position of the aeroplane. We'll just mark off this as B and C. All right. Passes vertically, this aeroplane, it passes vertically below another plane. The height of this plane above the ground is 3125 meters. At a particular instant, this plane passes below another one. That means there is something above it. This plane is passing below another plane. So that means that other plane is above it. The other plane is above it. This is the first plane. This is the first plane. This is the second plane. Because this one, see here, now look at this A. Isn't A below D? Isn't A passing below D? Isn't A passing below D? Yeah, it is below. A is below. That's what the question says. It passes vertically below another plane at an instant. They are moving in the air. At a particular point, they're exactly one below the other. Okay. At an instant when the angle of elevation of the two planes from the same point on the ground. So there is an observer looking at this scene. There's an observer on the ground. So let the position of the observer be C. This is the observer. This is the position of the observer. This is the position of the observer. Now, when this plane A is vertically below plane D, the observer C looks at that. Let's connect this also. It's one line segment, the whole thing. He looks now like when the planes are positioned like this, the observer looks at the two planes. What does he observe? He observes at an instant when the angles of elevation of the two planes from the same point on the ground. He's standing at one particular position on the ground. He doesn't move. From the same position, he looks at both the planes because they're one below the other. No, so he looks up and down. And he notices the angle of elevation are found to be 30 degrees and 60 degrees respectively. All right, now we'll have to mark the angles of elevation, 30 degrees and 60 degrees. Now, the thing is, which one is 30, which one is 60? See, like when you keep looking higher and higher, the angle of elevation keeps increasing because this is the horizontal. This is the horizontal. When I'm looking at something higher and higher, I have to look up. So the angle of elevation increases as you look at taller objects. The angle of elevation will keep increasing when you look at taller objects. So obviously, okay, now let's connect the lines of sight. So there'll be two lines of sight. Two lines of sight because he's looking at two different things. So two lines of sight. One is, this is the eye of the observer and this is the object observed. This is one line of sight. Then this is the eye of the observer, the same thing. But he's looking at this one. Sorry, all line segments, children. If mine is not exactly straight, please excuse me. Please excuse me. I don't want to rub it and roll again. All right. Now, these are the lines of sight. These are the two lines of sight. Eye of the observer, object observed. Lines of sight. Okay. What are the angles of elevation? 30 degrees and 60 degrees. So whichever is lower, the angle of elevation will be less. Whichever is higher, the angle of elevation will be more. So now this is the line of sight. This is the horizontal, 30 degrees. This is the line of sight. This one is a line of sight. And this is the horizontal. This one is 60 degrees. The angle between the horizontal and the line of sight, that angle is the angle of elevation. So, see, I'll show you again. 30 and 60, whichever is below, that one will be 30 degrees. So, see, this is the line of sight. This is the horizontal. This is 30 degrees. This is the line of sight again. This one is the line of sight. Line of sight, this is the horizontal, 60 degrees. From the line of sight till the horizontal. 60 degrees. This is the figure. How simple was that? That's it. Which is 3125. This one is 3125. This one is 3125. That's it. You make this figure correctly. Now you cannot go wrong in answering. Now find the distance between the two planes at that instant. Because now they've moved. They're in meaning their own ways. At that particular point, they were one below the other. What is the distance? You need to find this one. You need to find this one. So you need to explain your figure in short, okay? What is AB? AB is the what is AB? AB is the height of plane A. Plane at the position A, but we'll say plane A, okay? Plane A. Plane A and DB. DB is the height of plane D from the ground. Which is the position of the observer. C is the position. C is the position of the observer. Then just write out the angles of elevation. Angle ACB is equal to 30 degrees. Angle DCB is equal to 60 degrees. And which one is 3125? AB is 3125. What should you find? To find the distance between the two planes at that particular instant. That means you'll have to find AD. You'll have to find AD. So this basic description about your figure you must give. All right. So now you should take we have two right triangles. See, we have nothing to do with the triangle ACD. ACD is a triangle, but it's not a right triangle. So that's not going to help us in any way. It's just there. That's all. What will help us is only right triangles. So we'll only consider right triangles, not any triangle. So we have two right triangles, ABC and DBC. Now, which triangle to start first? Whichever triangle you have two information, start that. See, anyways, you can get the answer. That's a different thing. But if you want to know, if you want to, give the right stuff, you want to take off correctly, then look at the information, choose that triangle first, which has two information. Like it can be two sides or one angle and one side. Because in a trigonometric ratio, there are three things, one angle and two sides. A trigonometric ratio connects one acute angle with two sides. That's a trigonometric ratio. A trigonometric ratio connects an angle with two sides. So there are totally three things in a trigonometric ratio. So if you know two of them, you can find the third one. So we choose a triangle where there are two things. So in triangle ABC, we have 30 degrees and we also have 3125 meters. So I'll choose that first. Okay. So you can. So I choose it. In the other triangle, I don't know. I only know the angle. I don't know side. I don't know DB. I know AB, but I don't know DB. So I won't take that first. Even if you take it, you're not going to go wrong. But since we have information like this, we'll go with the convenient triangle first. So you write like this: in triangle ABC. Now you have to connect AB and BC. You'll have to connect AB. See, hypotenuse mostly will not help us. So don't find the hypotenuse. In some cases, we have to find the hypotenuse. That we'll see. When we take a question like that, I'll tell you why we didn't find in other triangles. That time I'll tell you. Now, mostly we don't find the hypotenuse. So if you see, we know AB, and if you're not finding the hypotenuse AC, then what should you find? BC only you should find. A triangle has three sides. You don't want to find AC, the hypotenuse. Okay. AB is given to you. Then which one should you find? BC only. There is no choice. So you have to connect that angle 30 degrees with AB and BC. So in triangle ABC, you need to connect 30 degrees with AB and BC. So it will be tan 30 degrees. Tan 30 degrees is equal to opposite AB by adjacent BC. So tan 30 is what? What's tan 30? 1 by root 3. Tan 30 is 1 by root 3 is equal to AB is 3125 by BC. So BC is equal to, on cross multiplying, BC is equal to 3125 root 3 meters. See, we got something. We got an answer. Like, now take up the other triangle. You have to work only with right triangles. There is no other choice. Here you will only keep working with right triangles. If this right triangle is over, take another right triangle, then another right triangle, like that. Nothing else you can do here. You'll have to simply take right triangles, apply trigonometric ratios, and yeah, and proceed like that. So in triangle DBC, in triangle DBC, which is the angle 60 degrees. 60 degrees. So you need to connect that with BC and DB. Now you understand. Hypotenuse we don't want. So you need to connect. So tan 60 degrees is equal to opposite DB by adjacent BC. Tan 60 is root 3. Yeah. Is equal to DB. I don't know. BC I just found. No. We just found BC 3125 root 3. All right. Now let's cross multiply. I'll just finish it in the slide. So I'll just do it here. So I'm cross multiplying. DB is equal to 3125 root 3 into root 3. I don't have place, so I'll write the answer straight away. You understand? 3125 root 3 into root 3. So it will be 3125 into 3. 9375. On cross multiplying, 9375 meters. So we found DB. What's the question? Find AD. What is AD? Correct. DB minus AB. So we have to find. Okay, so we have to find, you can write like this, AB plus AD is equal to what, children? What is AB plus AD? DB. Now what is AB? 3125, already given in the question. Plus AD is what I want to find, is equal to DB 9375. So AD is equal to 9375 minus 3125. So on subtracting 0, 5, 2, 6 meters. So the distance between the two planes at that particular instant was 6250 meters. All right. So Raja, you have not learned it in school, but was it clear to you? You can get it right. Yeah, very good. Yes, children, quickly make a note of it. Now you cannot think and write. Now you have understood. Just write it fast. You finished. Navya, where did you go wrong? Oh, okay.
Good evening, ma'am.
Yeah, hi Madhumita. Good evening.
Ma'am, I just joined the meeting a few minutes ago, like about the starting of the sum. I'll just watch the meeting recording for the previous sums, ma'am.
Okay, then. Okay. Yeah, online students completed.
Yes, ma'am.
All right.
Yes,
Madhusha,
ma'am.
kindly take a screenshot. The question is here.
Yes, ma'am.
Yeah.
Taken, ma'am.
Yeah. Solution.
Ma'am, I wrote the solution down.
Oh, okay. All right. Next one, children. From a window, 15 meters above the ground, the angle of elevation of the top A of a tower is phi. Greek letter phi. 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 Greek letter, nothing. From a window 15 meters above the ground, the angle of elevation of the top A of a tower is theta. Sorry. Now it's theta. I'm sorry. Phi comes later. Sorry. Is theta. Write down the question. And the oh, I'm so sorry. 1 minute. Let me just read out the question first. No, like it's congested, so I'm just skipping the lines. Please write down, children. From a window 15 meters above the ground, the angle of elevation of the top A of a tower is theta. And the angle of depression of the foot B of the tower is phi. Online students can see my screen right? I think there's a internet glitch for some time. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yeah, my screen visible, right?
Yes,
Yes.
ma'am.
Yeah. Please try this.
Completed, ma'am.
Done with the figure or solution, Madhumita?
Ma'am was supposed to draw the figure. Okay, ma'am, I didn't do it.
Yeah. No. That's what that's what I said. Yes. Okay.
Ma'am.
Yeah, let's see the figure now. Okay. So from a window 15 meters above the ground. So let's take the ground level. There's a window 15 meters above the ground. 15 meters. 15 meters. So this is the position of the window. For the window, we are using only a point. The height of the window above the ground is 15 meters. So that line segment represents the height of the window above the ground. Window is only a point. Window, you should not draw a window. Don't use a line segment for the window. Don't use a line segment for the window. Window is only this one. This is the window. Then what is this line segment? That's the height of the window. The window is 15 meters above the ground. No? So this is that height of the window from the ground, 15 meters. This is the window. Let me call it W. That's a window. From a window 15 meters above the ground, so the observer is here. So this will be the horizontal. Correct? The angle of elevation of the top A of a tower is theta. So the tower is somewhere here. This is the top A of the tower. Right? See, this is the ground level. This is the ground level. Ground level. This is the position of the window 15 meters above the ground. So this is the window and this is 15, the vertical height of the window from the ground. So the observer is looking through the window. The observer is looking through the window. So this will be the horizontal. This is the horizontal through the eye of the observer. Now there's a tower. You can take the tower this side, any side. Side does not affect your answer. Why you're drawing the line segment here? Why don't you take it that side? Okay, fine, we'll take it that side. The way the triangle is drawn does not affect your answer. So this is the tower. This is the tower. This is the top A of the tower. It's given there. The angle of elevation of the top A of a tower, meaning they're calling the top of the tower A. So even I've called it A. The angle of elevation of the top A of a tower is theta. So that means angle of elevation means there should be a horizontal, there should be a line of sight. Only then angle of elevation. Horizontal is through the window. This is the horizontal. Line of sight connecting the eye of the observer and the object observed, the point or the position observed. All right. If I draw it on the board with a marker, I have a better grip. Now with this, I'm not having a good grip to draw the lines. That's why they all look like bent. They're all perfect straight lines. Yeah. I don't want to erase and waste your time. Yeah. So this is the line of sight. This one is the line of sight. From the eye of the observer, that is through the window, to the point observed, A, is a line of sight. This is the line of sight. This is the horizontal. So this is the angle of elevation of the top of the tower. This one is the angle of elevation, which is theta. And the angle of depression, that means the observer is there only. The observer has not changed the position. Okay, time passed through the window. So the observer looks at the top of the tower, then immediately looks at the foot of the tower. So from here, he's looking at the foot of the tower. Here, this is the foot of the tower. From the same position, just imagine you're looking through a window, you're looking up at a tall building and you're looking down at the foot of the building. That's what it is. So from the same position, the observer is here only. From there, he's looking down at the foot of the tower. This is the foot of the tower. He's looking down there. And the angle of the foot B, so foot is B. The angle of depression, why depression? Because he's at a higher level and he's looking down at something. So angle of depression. The way we mark the angle is the same between the horizontal and line of sight. Okay, if the object is below and the observer is at a higher level, it is angle of depression. If the observer is looking up, it is angle of elevation. If he looks down, it's angle of depression. So he's looking down at the foot B. Now where to mark phi? Between the horizontal and the line of sight. Horizontal is the same horizontal because observer is at the same position. So same horizontal. This one only is horizontal. Horizontal will not change, same thing. But the line of sight is different. This is the line of sight. This is the line of sight. The angle between the horizontal and line of sight is called the angle of depression, which is phi. Now, if tan theta is phi, so the diagram we have made, then if tan theta is 5/3, and see, you only know that this one, let's mark these points A, B, C, D, like this. So we only know WD is 15 meters. If WD is 15, this one is also 15. This one is also 15 meters. Okay, so tan theta is given, tan phi is given. Find the height of the tower. Height of the tower is AB. We need to find AB, but it is enough to find AC because we know BC. You don't have to find AB. We have to find AB, but we know a part of AB. BC is 15. So it is enough you find AC. So whatever is AC plus 15 will be the height of the tower. So so what do you say here? Can you describe the figure? AB is the tower, right? AB is the tower. Then W is the position of the window. W is the position of the window 15 meters above the ground. Position of the window, you can just write dW is equal to 15. dW is equal to 15 meters. Then you can mention the angles. Angle AWC is equal to theta and angle CWB is equal to phi. Now we need to find AB, but it's enough to find AC. Yeah. So in right triangle, in simply triangle, you can use this triangle. What is this one called? BCW or WCB. This triangle. Can you see phi and can you see 15 degrees? I'll just select the triangle. We'll just select the triangle where we have maximum information, where we have many things known to us. So we'll go with that triangle. So there are actually two right triangles here. You can take one ACW also. AC, look at the board. You can also take ACW. But ACW, I only know theta. I don't know anything else there. So I'm scared. I'll not take that first. Let's take the other triangle, BCW. In BCW, we know two things. We know phi and 15. No, so let's try that first. Wherever we have more information, we'll try that first. So in triangle BCW. All right. So you have to connect BC and WC. So it's tan phi. Tan phi is equal to opposite BC by adjacent WC. Tan phi is given 2 by 3 is equal to BC is 15, WC we don't know. So WC is equal to, on cross multiplying, 15 3s are 45 by 2, which is 22.5 meters. All right. 15 3s are 45 by 2, 22. Or you can have this 45 by 2 itself. Now we'll have to take up the other triangle. In triangle ACW. In triangle ACW, again tan theta. Tan theta is equal to opposite by adjacent. Opposite is AC. Adjacent is WC. Tan theta is equal to opposite AC by WC. Tan theta is equal to AC by WC. Now we are given tan theta as 5 by 3. Tan theta is 5 by 3 is equal to AC, we don't know. By WC, I think we just found no 45 by 2 or 22.5, whatever. Okay, you can take this 45 by 2 itself. No, cross multiply. Cross multiply. So we'll get 3 into AC. 3 into AC is equal to 5 into 45 by 2. So AC is equal to 5 into 45 by 2 into 3. So 3 ones are 3. How many times? 15s are. So 15 5s are 75. 75 by 2, which is 37.5 meters. But we need to find AB. AB is equal to AC plus CB. Right? AC plus CB. Yeah. Yeah. So AC we just found is 37.5 plus 15, which is 52.5 meters. So the height of the tower, therefore, height of tower is equal to height of the tower is equal to 52.5 meters. Oh yeah, I'll turn it over some time. Just thank you.
Ma'am, can you please show the first question for a second?
Yeah, sure. Wasn't that super easy? Yeah, that's all it is. The whole of this chapter is just this. You just need to understand the information given and draw the diagram correctly, carefully. If you do that, I told you 50% done. Then it's all about taking triangles and working like this. Take the triangle, you should take only right triangles and you choose that right triangle first where we have more information. And once you start working, automatically see, we don't know we are going to get double C, but when you start working with that something, you find the required answer. Yeah, children, quickly write down.
Ma'am, could you please show the previous slide for a second?
Oh, previous slide, you mean which one?
Yes, ma'am, the question for this one.
The question for the second one is this, from a window.
For the first one.
Oh, yeah.
Thank you, ma'am.
Yeah, you're welcome. Done? Finished? No. Now you have to write down from the board. Or if you want to do it by yourself, I can do one thing. I'll share the images with you later. No, you might forget. You write it down fast. You can go home and practice from this. Yeah, Raja, நீங்களும் பண்ணக்கூடாது. டக் டக்குன்னு எழுதிக்கணும் போர்ட்ல இருந்து. Oh, okay. You? Finish writing, online students?
Completed, ma'am.
Yeah.
Completed, ma'am.
Okay. Done, Raju? Next question. All right. So let's understand the figure together, children. So this is the surface of the lake. This is the surface of the lake. Okay. Now there's a cloud 2,500 meters above the lake. So this is the surface of the lake. Say this is the position of the cloud. The height of the cloud from the lake, from the surface of the lake is 2,500 meters. This is the surface of the lake. From the surface of the lake, the height of the cloud is 2,500 meters. So cloud, and this is the surface, this is the point on the surface of the lake. The distance between the cloud and this point on the lake is 2,500 meters. Distance is always the perpendicular distance. It's a vertical distance. It's always the vertical or the perpendicular distance. Okay, this is what is given. Then the angle of elevation of the cloud from a point 2,000. The angle of elevation of a cloud from a point. Sorry. No, I misunderstood. No, I didn't read it correctly. Sorry. The person is, 1 second. The angle of elevation of a cloud from a point 2,500 meters above a lake. The observer, I mistook, meaning I didn't read it completely. Okay, so the observer is standing. The position of the observer is 2,500 meters above the lake. The position of the observer, because see here, the angle of elevation of a cloud from a point which is 2,500 meters above a lake. There's a point 2,500 meters above a lake. From that point, when you look at the cloud, the elevation is 30 degrees. The angle of elevation of a cloud from a point, that point is 2,500 meters above a lake. So this is that point which is 2,500 meters above the lake. From this point, when you look at the cloud, so this is the cloud. This is the height of the cloud from the surface of the water. The elevation is 30 degrees. So this is the horizontal. This is the horizontal. Because from here you're seeing, so this is the horizontal. And this is the line of sight. This is the line of sight. And between the horizontal and the line of sight is the angle of elevation, which is 30 degrees. And the angle of depression of its reflection in the lake. So the cloud is reflected below in the lake like this. So to say this is the reflection of the cloud. Okay. The angle of depression of its reflection in the lake is 45 degrees. So the observer is at the same point. From the same point, the observer is looking up at the cloud in the sky. The elevation is 30 degrees. And he looks down at from the same position, he looks down into the water, okay, and the reflected cloud or the reflection of the cloud. And he finds the angle of depression to be 45 degrees. All right, so see from here. So continue. Understand? From here, now don't draw the line from here. It is not this line. You cannot draw the line segment from anywhere. From the eye of the observer to the object observed. Not any line segment. So where is the observer? The observer is here. Then what is this 2,500? That's the height. He's probably sailing in a ship. The height of the ship is 2,500 meters, whatever. He's not floating on the water, right? He's at a height 2,500 meters above the water. So maybe he's on a boat or a ship or whatever. You have a doubt, Rajan?
This the as the lake.
Ah.
So if the reflection is on the lake level, it should be the
not on the lake, where the reflection will not be on the surface of the lake. No, it'll be down in the water. And the water is moving, so the reflection will keep shaking actually. The water is not still. It's a lake, huh? It's a lake, so it's still. So you're able to see the reflection. If it's moving water, the reflection will keep, like, yeah. What is your doubt actually? The reflection will not be on the surface of the water. It will be down. Whatever is the height of the cloud above the ground, at the same distance below in the water, the cloud will be reflected. It's like when you stand in front of the mirror. The distance between the mirror and you will be equal to the distance between the mirror and your reflection. Your reflection will not be just on the mirror, right on the surface of the mirror. It will look like that, but actually the distance between you and the mirror will be equal to the distance between the mirror and your reflection, right? Same thing here, same principle. Same thing here. So this is the reflected cloud in the water, deep down in the water. And line, so horizontal is the same thing. This is the horizontal. This is the horizontal through the eye of the observer. Line of sight from the eye of the observer to the object observed. This is the eye of the observer and this is the object observed. All right. So this one is this is the line of sight. And the angle of depression is 45 degrees. Where will you mark it? Between the horizontal and the line of sight. So this is the horizontal, this is the line of sight. The angle of depression is 45 degrees. Correct? No, have I answered your question, Rajan? Okay. Now, what is the height of the cloud above the lake level? So you need to find this one. You need to find this. So let's mark off. We'll just call this A. All the points should be marked. So A, B, C, D, E, F. Okay. So CA is the height of the cloud. Height of the cloud above the lake. E is the position of the observer. E is the position of the observer. FE is equal to 2500 meters. Angle AEB is equal to 30 degrees. Angle BED, yeah, is equal to 45 degrees. And we need to find, all this is given with all this information, we need to find AC or CA. CA or AC, whatever. But you don't have to find the full line segment because you know this one is 2500. You only have to find AB. You don't have to find, you have to find AC, but a part of it is known to you. BC is 2500 because in a rectangle opposite sides are equal, correct? So this one is 2500. So you just have to find AB. AB plus 2500 will give you the height of the cloud above the lake. Correct? All right. Now let's mark off, what all we can, further understand from this information. So this one, as we said, is 2500 meters. This one. And now supposing, see, whenever we have line segments of equal length, it's better we use variables X, Y and all that. Whenever you think that there will be line segments of equal lengths. Because here we know that the distance between the surface of the water and the lake, the distance between the surface of the water and the cloud is equal to the distance between the surface of the water and the reflected cloud. We know that. So there are some line segments equal here. So please use variables X, Y, Z, whatever. So where to use a variable? Okay. So here, this one, this one, you call this one as X. You call this as X. So what is CA? How much is CA? Yeah, okay. In terms of the number and the variable we have there. Yeah, CA is 2500 plus 6. Now tell me a line segment which is equal to CA. CD. Surface of the water, cloud. Surface of the water, reflection. Surface of the water, cloud is CA. Surface of the water, reflection is CD. CA is equal to CD. That's what I said. When you think some line segments will be equal, please use variables X, Y, Z. Okay, so now we know that CA is equal to CD. CA is equal to CD. So CA is equal to CD. CA is how much? CA is equal, you can just say let. So writing is freestyle, It's not letter writing that you should write it in this format. It's freestyle. So let Nothing like this comes first, this comes next. So see here, let AB be equal to X meters. X meters. So then what is AC or CA? CA is equal to 2500 plus X meters. Now we know that CA is equal to CD by the laws of reflection. By the laws of reflection, I'm not writing all that. You understand, by the laws of reflection, CA is equal to CD. Okay, therefore, CD is equal to 2500 plus 6 meters. Now tell me how much is BD? BD. We're trying to find what all possible. How much is BD? BD. Because BD, well, now the next thing is why is she finding BD? Why should we find BD? Because BD is the side opposite to 45 degrees. No, so we have to use that side. When we use trigonometry, we will be using that side BD. So we're trying to find BD. We have to find out when you take up the triangle 45 degrees, the side opposite to 45 degrees is BD. So let's find BD. What is BD? X plus very common mistake. I like it when children make that mistake so that you don't do it in the exam. So my question is how much is BD? And for that your answer was X plus 2500, right? Okay, you keep the answer with you. And we are online students.
Ma'am?
Yeah, BD. How much is BD?
X, ma'am.
BD.
Ma'am, I also think it's X plus 2500.
Okay. Others, Prajit, Rakshita. Is Rakshita there? Yeah, Rakshita is very quiet these days. Rakshita and Danya are very silent these days, huh? What are you doing? Rakshita and Danya. Yeah, girls, tell me. BD. BD is equal to?
X plus 2500, ma'am.
Please think again. Okay.
Ma'am, it's equal to E.
X minus 2500.
Yes, Danya. Once again.
X minus 2500.
X is only AB, no? X is only AB.
Ma'am, it's equal to ED, ma'am.
No. How is it equal to ED? Why? Because angle is 45, huh?
Yes, ma'am.
How will the hypotenuse be equal to something?
Yes.
None.
X plus 50,000.
Again?
X plus 50,000.
Not 50,000. 10 extra.
5,000.
No, it shouldn't be like, okay, if it's not 50,000, fine, take 5,000. What is the answer? X plus 50,000 or 5,000?
5,000, ma'am.
Yeah. What is BD, children? See, look at that line segment BD. Isn't it BC plus CD? Isn't BD? Okay, now we have a doubt with X. X is only AB. AB alone is X. ABC, we have put the bracket there, no? AB alone is X. BC alone is 2500. No. Opposite sides are equal. BC alone is 2500. AB, that rest of it, AB, I'm not calling the whole thing as X. See, that's why I've used a bracket. And I've also described it here. See, I've written here AB is equal to X. I normally don't call the whole thing X and then X minus. Why? If something is already 2500, the rest of it is x. Why call the whole thing x and then say the remaining is x minus 2500? Don't do all that. One segment is 2500. The one above it is x. That's all. Okay. No, now look at the board. What's your name? Sri Ranjan. BC is how much? Louder. BC. AB. X. How much is AC? Look at the board and tell me. AC. 2500 plus x. Okay, now AC is equal to what? By the laws of reflection. AC is equal to CD. Because which is like the mirror here? Which is the source of reflection or the surface of reflection? The lake, the surface of the water is a source of reflection. So CA is equal to CD, right? So if what is CA? Then what is CD? I'm not sitting with a stick to beat you. Otherwise, you're so bold. The other day when I asked you why you didn't tell me that you're not coming to the physical class, you had one big story to tell me. Now answer my question. CA is how much? X plus 2500. CD? Same thing, X plus 2500 because laws of reflection. Now, so CD is equal to X plus 2500. How much is BD then? BD, this one from here to here, from BD. BD is BC plus CD. BD is BC plus CD. How much is CD? CD is this one. Then how much is BC? 2500. Then how much is BD? 2500 plus 2500 plus X. So X plus 5000 it is. X plus 5000. I'll write it here, children. This doesn't come first. I'm continuing here. So BD is equal to BC plus CD. BC is 2500. CD, by the laws of reflection, 2500 plus X. So X plus or 5000 plus X meters. Now let's start using the triangle. So we could find so much with the information given. And why suddenly X I used? Because I told you here we can, since by the laws of reflection, some line segment will be equal to some line segment. We want to use X. Okay. All right. Now let's take up the triangles. So the triangle in which we have 45 degrees. In triangle, the triangle in which we have 45 degrees in triangle, BED, tan 45 is equal to okay, so in triangle BED, tan 45 degrees is equal to the opposite side, children, is BD. All right, the adjacent is BE. What is tan 45? 1. And BD, we all found together, BD is 5000 plus X. Okay, and BE, we don't know, by BE. So on cross multiplying, we have BE is equal to 5000 plus X. Now the other triangle. In triangle, now the other triangle. In triangle, AEB, tan 30 degrees is equal to opposite. What is opposite? For 30 degrees, which is the opposite side? AB, and that is X. AB by adjacent BE. Tan 30 is 1 by root 3 is equal to AB. We've called it X by BE. What's that? 5000 plus X. Now cross multiply. So root 3x. Root 3x is equal to 5000 plus x. Root 3x minus x. See, whenever you're working for x, you should have all the x on one side. When you're working for x, have all x on one side. So x common, root 3 minus 1 is equal to 5000. So x is equal to 5000 divided by root 3 minus 1. You'll have to rationalize the denominator with the conjugate root 3 plus 1. So x is equal to 5000 into root 3 plus 1 divided by a minus b into a plus b is a squared minus b squared. So 5000 into what is root 3 plus 1, children? 1.732 plus 1, 2.732. 2.732. 1.732 plus 1 is 2.732 divided by 3 minus 1, 2. 2. Then 2 ones are 2,500 times. So 2,500 into 2.732. Is it given root 3's value? No. So it's 2,500 into 2.732. Oh my God. 6830 exactly. Very nice. 6830 meters. Now x is 6830. X is 6830. Oh, we have to find AC. The height of the cloud from the surface of the water. We have to find AC. So what is AC? AB plus BC. AB plus BC. We have to find AC. We have to find AC, which is AB plus BC. Or we have already written here, children, ACC. AC, where C, we have written, we'll use this directly. We have written here CA, 2,500 plus X. We'll use it straight away. 2,500 plus X, we've already written. 2,500 plus X. So AC is equal to 2,500 plus 6830. 0339. So the height of the cloud above the lake is 9330 meters. Right? Write down quickly. Quickly and carefully. You need to refer, so write it carefully. You make one mistake, then you will not understand and yeah.
Completed, ma'am.
Yeah.
Completed, ma'am.
Okay, for the online students, I'll show you the next slide. Just take a picture because here in the class, we are still writing the first slide. Take a picture so that you can continue if you have completed the first slide.
Taken, ma'am.
Yeah. Done, boys? The first slide? Navya? First slide is over? Okay.
Is not given and stop there.
Where, no, when the value of root 3 is not given, you should take 1.732. If it's given, it may be given. If it's given, maybe it's given 1.732, otherwise 1.7 or 1.73. If something is given, take that. If nothing is given, you have to take 1.732 and proceed. You're saying we'll stop here without here, huh? Where? This one. இல்ல அப்படி பண்ணக்கூடாது. ஓ இங்க வந்து root 3 value போட வேண்டாம்னு. No, you should take. You must take. You must take the value of root 3 as 1.732. Okay, was any instruction like that given to you by your teacher? See, NCERT bookல வந்து நிறைய ஆன்சர்ஸ் வந்து அப்படியே root 3லயே இருக்கும். அதுக்காக அது கரெக்ட்னு கிடையாது. As a student, we have to take the value of root 3 and give the final answer as a decimal. See, but in decimal கூட இல்ல. See, we got 6830 itself. So this answer is எதுக்கு இப்படி வைக்கணும்னா this is more easy to understand, right? When I say 6,830 meters, we understand what it is. But if you use this complicated math 5,000 or if you say 2,500 into root 3 plus 1, you're not able to gauge how big or small that is. Correct? 2,500 into root 3 plus 1, I don't understand. But when you say 6,830, yeah, we understand 6,830. You can imagine that height or whatever, right? So never stop there. But yes, answer in the textbook is mostly in root 3 and all that. As students, we have to complete it like by taking the value of root 3. If it's root 5, root 7, the value will be given to you in the question. It will be given. It will be given. Finished? Done? Ranjan? All of you completed online?
Completed, ma'am.
Yeah. Yeah. Next one. Yeah. So the pilot of an aircraft flying horizontally. Okay, he is flying horizontally. The pilot of an aircraft flying horizontally. The aircraft is flying horizontally at a speed of 1,200 kilometers per hour. The pilot observes that. Okay, the pilot observes that the angles of depression, obviously, so he's flying high in the sky. So if he looks down at something, if he's looking down at the object, so it's angle of depression. The angles of depression, so he's looking at two things. The angles of depression of a point on the ground. Okay, so he's looking from there, he's looking at a point on the ground. The angles of depression of a point on the ground changes from 30 degrees to 45 degrees in 15 seconds. It changes from 30 degrees to 45 degrees in 15 seconds. Find the height at which the aircraft is flying. So one thing is, you know the speed of the aircraft, and you know the time in which the depression changes from 30 to 45 degrees. So using speed and time, you can find the distance covered by the aircraft in 15 seconds. See, you know the speed, you know the uniform speed of the aircraft, and you know the time taken 15 seconds. The time taken 15 seconds is the time in which the depression changes from 30 to 45. So that is a line segment, no? So the length of that line segment or that distance is that distance can be calculated using the formula distance is equal to speed into time. Okay, now how do we make the figure for this? Now, let me not say that. The observer, does he take two different positions, or are there two different points on the ground? Observer takes two different positions because the observer is moving. So he sees the point on the ground, the depression is 30 degrees. Then he's moving, right? So he looks at the same point. After some time, his position has changed. But he looks at the same thing on the ground. The depression is 45 degrees. You understand something? So the observer is taking two different positions, but he's looking at the same thing on the ground. So the point P on the ground is the same. He's looking at the same point P on the ground from two different positions because he's moving. So at a point, he looks at a particular instant, he looks at the point on the ground. Depression is 30 degrees. The plane is moving. So after some time, that is after 15 seconds, he looks at the same thing on the ground. Depression is 45 degrees. He takes two different positions. The object is only one here. Okay. And the depression changes from 30 to 45 in 15 seconds. So say this is the position of the aircraft at a particular point. Okay, see, so these are the two positions. These are the two positions of the aircraft. So their vertical height from the ground. Vertical height from the ground. Correct? So this is the ground level. This is the ground level. Okay. Do you want me to come again? See, take the two positions of the observer. Take the two positions of the observer. Two positions of the observer. The height of the observer from the ground. The height of the observer from the ground. He's flying, maintaining the same height from the ground. He's going ups and down, then you cannot find anything. He's flying horizontally above the ground. This is the ground level. This is the ground level. Say this is the object on the ground. This is the object on the ground. All right. So which is the line of sight? Okay, which is the horizontal? The horizontal will be this one. This is the horizontal. That's the horizontal. Line of sight. Line of sight is from the observer to the object observed. So observer, object observed. This is one line of sight. Observer, object observed. This is the other line of sight. This is the other line of sight. Correct? Now the angle of depression changes from 30 to 45. So here also, that means he's coming closer to the object. He's coming closer to the object. So that you can just imagine, see, like at a particular point, you're looking at a point on the ground, the depression is 30 degrees. When you come closer, like when the point is right below you, the angle will be more. You'll have to look down more. See, like you're looking from the balcony, if you're looking at something away, the depression is less. But from the balcony, if you're looking at something which is close to the foot of the building, we'll have to look down, right? So the depression is more then. So the pilot or the aircraft is flying towards the point. That's why the depression increases. The depression, the angle of depression will increase when the flight is going towards the point. It's going towards the point. The point is here. See, the aircraft is flying like this. As it comes closer, the elevation will keep increasing. Now you will be like, now how do I think of so much in the examination hall? Nothing, you don't think of anything. This angle is smaller than this one, right? So obviously this is 30 degrees, this is 45 degrees. That's all. So you cannot go wrong. So see here, where do we mark the angles? Between the, okay, one, I didn't show you the angle of depression. From there, I have to come down to the angle of elevation. Okay, so now this is the horizontal. I've shown you the horizontal, the lines of sight, correct? These are the lines of sight, correct? Now, the angles of depression I didn't mark. I was trying to tell you, you don't know if you have to put 30 degrees here and 45 degrees here. or 45 degrees here and 30 degrees here. That might be a doubt. I'm just assuming that. Okay, that might be a doubt. If just 1 minute, children. Yeah, so what we have understood is the angle of elevation or angle of depression is marked between the horizontal and the line of sight. Horizontal and the line of sight. Okay, so what you have to remember is when the plane is coming towards the object, the depression will increase. If it's going away from the object, the depression will decrease. If the depression becomes from 45 to 30, from 45 it's becoming 30, that means the plane is going away from that point on the ground. If the depression increases, like in this case from 30 to 45, that means the plane is flying towards that point on the ground. So the point is here on the ground. The depression increases from 30 to 45 degrees. That means it's flying towards the object. The plane is flying towards the object. What am I saying? If the plane is flying towards the object, depression increases. If the plane is flying away from the object, which is observed, then the depression will decrease. Okay, so that means this is 30 because it's flying towards, no. So here it was 30 degrees. Here it becomes 45 degrees. It's flying towards. And where have we marked 30 degrees? Between the horizontal and the line of sight. And where 45 degrees? Between the horizontal and the line of sight, 45 degrees. And now we know that angle of elevation is equal to the angle of depression. So if this is 30, this one is 30 degrees. You know, no, that Z is, so here and here. You can see the Z from here. 30 degrees. And then this Z. So this one is 45 degrees, this one. Angle of elevation is equal to angle of depression. All right. Now all this is happening in 15 seconds. Now what do we know? We know speed and time, right? So what is distance? Distance is equal to, 1 second, what is this? We'll call it A, B. This is the point observed, C, D, E. All right, let me just write it here. So A and B, A is the first position. Or you can just say A and B are the two positions of the plane. A and B are the two positions of the plane of the aircraft, or okay, of the aircraft. C is the object. What is it called here? Point on the ground. C is the point observed. C is the point observed. Okay, then if you have to write this angle 30 and 45, you'll have to take a point here. Otherwise, you cannot name the angle. So just take a point like so angle FAC. Angle FAC is equal to angle FAC is equal to AC D or E, whatever. ACD or E. ACD E, whatever, is equal to 30 degrees. And angle FBC is equal to angle BAC. CE, correct? BCE is equal to 45 degrees. And what should you find? To find AE or BD. AE or BD. To find AE or BD. Correct? Okay. So see, two line segments are equal, no? Call it X. So let AE is equal to BD is equal to X. Because they're equal, you understand that. So whenever two line segments are equal, call them X. Otherwise, what will happen? No, in one particular working, you'll have AE. In another working, you'll have BE, BD. Both are the same, but you will be looking at that as AE and this is BD without realizing that they are the same. Supposing you, okay, that's what it is. In one particular working, you have AE. In another one, you have BD. You'll be like, I got, no, that's what, you'll not be able to relate. You'll think that's different, this different. But when you use the variable X, it becomes easier for you. So AE, BD, let it be X. Yeah. Now, the first thing is, see, we don't know any line segment at all. No number, we only know 30 degrees, 45 degrees. With this, how can you answer the question? You need the length of some line segment, some little line segment. You need to know the length of any small line segment in the figure. Otherwise, you cannot find any numerical value. You cannot answer this question, find the height at which the aircraft is flying. You only know angles 30 degrees and 45 degrees. All right. Yeah, so we need to find the length of some line segment. So we have the speed and the time there. Distance is equal to speed into time. Okay, but take care. Speed is given in kilometers per hour, but time is in seconds. So we'll convert seconds to hours. So we'll just do that conversion first. Or you can even convert 1,200 kilometers per hour to meters per second. Meters per second, whatever you want to do. If you want to do that, so speed is equal to 1,200 kilometers per hour. And what's that ratio? 5 by 18 or 18 by 5? How do you convert kilometer per hour to meter per second? 5 by 18 or 18 by 5? 18 by 5. Yeah. This is your question, children. How do you toggle between speeds in kilometer per hour? How do you convert kilometer per hour, speed in kilometer per hour to meters per second, and the vice versa?
I'm 5 by 18.
The first one is 5 by 18, is it?
Yes, ma'am.
Correct. The second one?
18 by 5.
Yeah. I'll just write it again. Just in case you've forgotten, you please make a note of this. Kilometer, please write all of you, kilometer per hour to meter per second conversion. Somewhere on the top in your book. Meter per second, you should multiply by 5 by 18. Meter per second to kilometer per hour. You need to multiply by 18 by 5. Make a note of this. So we need to convert speed, which is in kilometer per hour, to meter per second, because time is in seconds. Fine. So 1,200 into 5 by 18. So in the tables of 6, what is it? 200. And tables of 6, 3. So let's have it as 1,000 by 3. Don't take the trouble of putting it into, a decimal form and all that. So speed is equal to 1,000 by 3, what? Unit. Meter per second. Meter per second. Okay. Now, I don't know how to get rid of this one. All right, then the time is 15 seconds. Time is 15 seconds. Distance is equal to speed into time. So distance is equal to speed, which is this one, into time. So 5,000 meters. What is this 5,000 meters? The distance covered in 15 seconds is 5,000 meters. AB. From A to reach B, the time taken is 15 seconds. Why? Because for the depression to change from 30 to 45. From 30 to 45, what is the distance covered? AB. That AB distance is 5,000. Correspondingly, the distance on the ground, ED is also 5,000. ED is also 5,000. So 5,000 is so AB, therefore, AB is equal to 5,000 meters. This means, this implies ED is also 5,000 meters. Now we need to use right triangles. Can you do this then? Yeah, do this, children. Take down. Complete this slide. We'll do it together. Write down the contents of the slide. We'll do it together. All right. Finished writing the content of this slide, children? Finished. Online students?
Completed, ma'am.
All right. Okay, so now in triangle, any triangle, in triangle BDC. BDC. What is the angle in triangle BDC? What is the angle in triangle BD? 30 or 45 degrees?
45.
45. So tan 45 degrees is equal to, tell me the two sides. BD by
BD by DC, ma'am.
very good. BD by DC. Tan 45 is 1. BD we don't know, but we've called it X, right? We've called it X, so we'll use X by DC. DC is DC only. Do we know DC? We don't know DC, so DC is DC. You can even call DC Y if you feel like why only this one is X. Please mark this as Y, children. We've called this one as X. X. So you can call this DC as Y. You can call DC as Y. Huh? That is ED. From 30 degrees to 45 degrees. 30 degrees is point A. 45 degrees is point B. A to B is 5,000. On the ground, ED is 5,000, not DC. Yeah. So you can call DC as Y. When you use variables everywhere. If you use line segment in one place, variable in the other, doesn't look good, you know. So we'll use variables everywhere. So DC, we'll call it Y. So here it will be DC. So Y. So we have X is equal to Y. Nothing can be found. So fine. Next, in triangle, the other triangle, in triangle AEC. And in this triangle, we have 30 degrees. Tan 30 degrees is equal to opposite. Which is the opposite side? For 30 degrees? AE. AE by adjacent? EC or CE? Very good. Tan 30 is 1 by root 3 is equal to AE X by EC. How much is EC, children? ED plus DC. So 1 by root 3 is equal to X by ED is how much? 5,000 plus DC is X. DC is Y. No, nothing to get confused. Yes, what is your doubt? Ask me. No, your doubt was only about 5,000. Where 5,000, right? Yeah, from A to B, A 30 degrees, B 45 degrees. A to B is 15 seconds. And AB, distance AB is 5,000 meters, which is ED on the ground. ED is equal to 5,000. We've written that here. Didn't write? Here I've written. AB is 5,000, so ED is 5,000. Right on top I've written there. Then we use one triangle, tan 45, and we get X is equal to Y. So use other triangle. And then there we get some. See, what I told you is when you use letters like variables like X, Y, use it everywhere. Don't have one line segment, one as X. Again, confusing. If you're using X, Y, if you see, I forgot to mark Y. So what did I do? I went back and I marked. I went back and I inserted DC is Y here. That's all. If you forget, go back and insert. When you realize, oh, there is X and then there is a line segment A, B, B, C, go back and say that is Y. Like I just did. I went back and I just inserted DC is equal to Y there. Yeah. So now everything is like, we don't have anything like A, B, B, C and all that. Everything is X, Y or numbers. Okay. So now here also we did not get anything. Here also we are not getting anything because we have two variables X and Y. So what can you do? You can substitute. What should you find actually? You should find the height at which the aircraft is flying. That is, you have to find X. You'll have to find X, right? Yeah, we have to find X. That means you don't want Y. You don't want Y. You want That is the equation you are working. You don't want y, you want only x there, right? So what you do, 1 by root 3 is equal to x by, I don't want y, so I'll put it as x because x is equal to y. See, you can either replace this y with x or you replace this x with y. So then this equation will have only one variable, x or y. Okay, let me do both. 1 second. 1 second. See, because x is equal to y, because x is equal to y, at this stage, what you can do, you can do two things. You can do two things. What are the two things you can do? You can either write 1 by root 3 is equal to, instead of x, you can say y by 5000 plus y. Or you can do, instead of y, you can put x. மேல இருக்கிற x y மாத்திட்டு கீழ இருக்கிற y x மாத்திடாதீங்க. ரெண்டுத்தையும் மாத்தக்கூடாது. ஏதான் you decide which variable you want to have. You want x or y. If you want y, have y. Where there is x, you put y. Because x is equal to y. No, I think it doesn't need so much explanation. You understand? Here we have an equation where there is x and y. So you know you cannot solve and find anything there. But we have a condition x is equal to y. So now the doubt is, should I take out x and write y? Or should I have this as it is and take out this and put x? Is a doubt. Do whatever you want. If you want to have x and y you removed and put x. Or the other way. Do whatever you want. Both you will get the answer. But what I'm doing is, because we have to find x. X and y are equal. Even if you find y, that is only x answer also. So I'm having x as it is. And because x is equal to y, 5000 plus y, right? So 1 by root 3 is equal to x by 5000 plus x. Using 1. This one is using 1. Cross multiply. Root 3x is equal to 5000 plus x. So gather all the x terms on one side. 5000. So root 3 is x is common. Okay, so x common, bracket root 3 minus 1 is equal to 5000. So x is equal to 5000 divided by root 3 minus 1. Don't use the value of root 3 here. Here you should not say 1.732 minus 1. You should not do that. You should, whenever the denominator is irrational, you have to rationalize it. So into root 3 plus 1 by root 3 plus 1. Rationalize it. 5000 into root 3 plus 1 divided by root 3 the whole square minus 1 square. So 3 minus 1, 2. So x is equal to 2500 into what is root 3 plus 1? 2.732. And we got some answer earlier for this. 630. 6830. Yeah. Yeah. That's it. So here it was a different situation, but again, it's easy. First equation, we got x is equal to y. In the second one also, when you took the first triangle, you got x is equal to y. You didn't get any numerical answer. So you took the second triangle, there also you didn't get any answer, like you're having x and y. But you realize that if in one equation you have two variables x and y, you cannot work and find anything. So what you do, you substitute. Where there is y, you use x because x is equal to y. So now in that equation, you have only one variable x. This you can solve and you can work the equation and find the value of x. So x is 6830. That means the aircraft is flying at a height of 6830 meters above the ground. Therefore, height of the aircraft above the ground all right. So you should remember how to convert kilometer per hour to meter per second. What's the number? Multiply by 5 by 18. Meter per second to kilometer per hour, 18 by 5. You can remember like this. So when you're converting to kilometer per hour, you should get a bigger value, right? When you're converting meter per second to kilometer per hour, you should get a bigger value. The answer in kilometer per hour will be bigger. So this is an improper, this is a proper fraction. Its value is less than 1. This one is an improper fraction. Its value is greater than 1. 18 by 5 is greater than 1. 5 by 18 is a proper fraction. It's less than 1. So when you're converting kilometer per hour to meter per second, this is a smaller one, right? You're converting it to meter per second. So into this proper fraction 5 by 18. When you're converting it to kilometers per hour, this one is a bigger, meaning the unit is huger. So use a improper fraction whose value is greater than. Is that fine, children? Any questions? Yeah, online students, use the emoji, raise your hand. Rajat, Dilipan, Krishni, Madhumita, Florentina, Rakshita, Danya, and Arjun. All right, children. All right, children, I'll just start the meeting. So it's time. That's it for today's session. I'll start the meeting and we need to decide the day and time for the compensation class, children. Please wait.